Hello, welcome back to Ken O'Connor Racing. What we have here is a 1995 Kawasaki KLX 650C. And what we're going to do with this, we're going to be cutting the valve seats, 3-angle valve job. Got brand new valves, Kawasaki valves, brand new springs, stock springs. Got a Wasner piston to the top of your screen on the right. That's 80 over. And we're going to be boring the cylinder, honing the cylinder. Basically just some maintenance. This thing's got a lot of miles on it. Camshafts look beautiful, but we'll show you what we're up to. Went ahead and cleaned all of our parts up. These have all been through the Media Blaster and the ultrasonic cleaner. The first thing I'm going to do is, paying attention to the cylinder head here, I'm going to go ahead and put this on our granite surface plate, and we're going to lap that surface, and we're going to do the same thing to the top of the cylinder. That's what we got. I went ahead and lapped the top of the cylinder and the cylinder head. This way, I mean, it's a good insurance policy. We're not going to have any problems, and I certainly don't want any. I don't charge my customers for this stuff. You send a valve job in here, we just do it automatically. So next thing I guess we're going to do is get the cylinder all bored, and then we'll hit the head. Got my cylinder bored out, 80 over, standard size. And I'm going to put this aside, we'll hone it later, and next thing we're going to do is look at the valves and the cylinder head and start cutting some seats. Here's my setup for the calculation of what I'm going to do with the seats. Because of the nature of this bike, this is, on off-road. I'm really not sure what the guy's doing with it, but I had a lot of miles on it. I'm figuring it's on the road quite a bit. This is not a motocross bike, so I'm not going to treat it like one. With that being said, I'm going to run my valve seats at 1.5 millimeters or 60 thousandths. The whole thing with valve seats is when they get thinner, they flow better, but they don't last as long. This guy I think had 8,000 miles, 5 to 8,000 miles on this thing, and I want to make sure he gets at least that, maybe more. So with that being said, I'm going to run a wide valve seat on it. I'm not so concerned with all kinds of performance with this, more or less longevity. So with the picture up at the top, on the left-hand side, my exhaust valve, I measure that, and it's 1.3 inches in diameter with a seat width, the ceiling width on the valve of 118 thousandths. On the right side, the intake valve comes out at 1 inch 497, and I checked it, it didn't measure 1.5 inches, which is kind of weird. This thing mic'd up almost like a Chevy head. 1.5, even though it's an intake valve on this bike, 1.5 valve on a Chevy is the exhaust valve, and the bore on this was 4 inches and 17 thousandths, which is usually one size, two sizes over on a Chevy motor. Just kind of neat, and just something I noticed. But the width on the intake is 110. So what you do is you take the 60 thousandths that I'm using for a seat width, you subtract it from the 110, and you come down and do your next math problem. And I came out with a width, a seat width on the left side, the exhaust, of 1 inch 242 thousandths, and on the right, the intake valve, 1 inch 447 thousandths. And the way I get that, I've got some markers here because you can't see what I scratched on the paper. I just use a pair of calipers, and I scratch a very faint line on a piece of paper, and then I bring my dividers into the picture and just match the dividers to that, and that's what I'm going to use to cut the seats. We're going to be doing a 3-angle valve job on this thing, and we'll show you how we get that done. I'm just going to assume you don't know anything about this, and I'm sure a lot of you guys watching it do, and if I'm getting redundant and boring you, please just shut it off. Don't send me bad comments. You'll never get an opportunity to see another one of these videos. I'll just ban you for life. So this is for the guys that don't know anything about this. Keep that in mind. Alright, from this little picture, here's an exhaust valve. See that shiny part? That's a 45-degree angle. What that means is that angle is at 45 degrees to the stem of the valve. So what we're going to do, the 3-angle valve job, is we're going to cut the 45-degree, and then we're going to use a 30-degree cutter and a 60-degree cutter to pull the width of the valve seat right in where we want it. And again, keep in mind, this seat width is going to be 1.5 millimeters, 60 thousandths, and we scaled our dimensions for the top, and we'll figure the bottom out as we go, but it's the same thing, intake or exhaust, it doesn't matter. I went ahead, I cleaned all the valve guides, and I actually ran a little hone. We have little ball hones for these things, and just to scratch them up, make sure they're going to hold some oil. So the valve guides are all prepped. The way we're going to cut the seats is with these little devices. These are New Way cutters. I've been using these things for a long, in my early 20s I think is the first time I started using these. It's a good product. There's definitely better ways of cutting seats, but there's no way you're going to see me spend $250,000 for a new one machine. It's just not profitable to do it like that, and that's part of the way I keep your prices down. So we're going to show you how we cut these seats with these New Way cutters. First step is to go ahead and paint the seats with some Dykem bluing. This is just going to act as a visual aid. That's all it's going to do. So when I start cutting my angles, I'm going to have really sharp lines to be able to make an accurate measurement. Okay, there's a lot of different techniques for doing this. I've got my own. I'm sure a lot of other people have theirs. But what I like to do, I like to come in and just trim the top angle to 30 degree and then go in and just trim the bottom a little bit. And keep in mind, I'm not cutting a lot off of these things. I'm just making a nice surface for the new valves to seal on. I went ahead and measured that line that you see that's blue. That's the 45 degree that we're looking for. I went ahead and measured that, and I'm very, very, very close to the dimension that I want to be at. Keep in mind, I can use the 30 degree cutter. If the seat comes in too wide, I can use the 30 degree to come in and narrow it down. If the seat is too fat, I'll use my 60 degree cutter at the bottom to narrow it back into where I want it to be at my 1.5 millimeters or 60 thousandths. So at this point, I'm going to go ahead and I'm going to cut the 45 and we'll see what it looks like. Alright, so that seat is dialed right in. I mean, I took my measurements, everything looks good. I'm going to continue, go ahead and cut the rest of the seats. Keep one thing in mind. These are stainless steel valves on this engine, so I can go ahead, I can lap these things. You can't lap titanium valves, you can't mess with them at all. There's a coating on them, and if you go ahead and you lap that coating off, you're in big trouble. I'll give you a piece of advice. If you want to do a head and seal it wicked tight with these New Way cutters, and you have titanium valves, just buy a titanium valve, buy a separate one, and you can use that valve to lap it in, get your measurements, seal everything perfect, and then just keep it as a tool. I mean, you're really not going to wear the valve down. You get a year out of it, and yeah, it's an additional expense, but it's ensuring that you're getting a tight valve job. This is critical to engine performance. A four-stroke engine is only as efficient as its leaks. If you've got a lot of leaks by valves, it's not going to run right. It's not going to run good, and it's not going to perform well. So take your time with this. If you're interested in these New Way cutters over here, these things are not cheap. They don't give these things away. I probably got about 30, 35 of them in here. Over the years we buy them and collect them. But if you just want to do a one-off valve job, definitely not worth buying them. But if you're going into the business and you want a inexpensive way to do it, this is definitely the way to do it, and it works well. I'm going to go ahead and cut the rest of the seats. Got all my seats cut and roughed in. I mean, they're really, really close, but there's a couple other things I want to check. Next thing I'm going to check is the valve protrusion measured from the height of the cylinder head on the inside where the spring makes contact to the tip of the valve, and I just want to make sure they're both the same. So both my exhausts are the same, both my intakes. I don't want to have a hard time shimming this, and I don't want my customer to have a hard time shimming it. So okay, I set the protrusion of the valve so everything's the same. Intake and exhaust are both different. Some heads are the same. This one not the case. And the only other thing I can point out, when you do this, use the same valve for the intake. So if you're don't use two different valves. Use the same valve, and you'll get an accurate measurement like that. And then measure your valves. Your valves, we just don't like leaving anything to chance. Your valves are going to be very close to the same length. But if there's a difference, you just want to make sure that you're getting the valves seated in the pocket the same. And then there's an adjustment you can make to the top of the valve. You can, if you have to take a thousandths off the stem, and that's perfectly acceptable as long as you have room for your keepers. And a thousandths, 2 thousandths, 3 even, don't even worry about it. So next step is, now I have to go back and correct my seats. I had to correct one intake, and the customer did tell me he had a leaking intake valve. That was the biggest problem here, so I got to go back and correct all my widths on that one seat, check everything again, and then after that I'm going to lap the valves. Okay, I've got all my angles corrected, all my widths corrected, the seat width corrected. To the best of my knowledge. So the next thing to do is we're going to go ahead and we're going to lap these valves in. I'm using some Felpro Clover valve lapping compound, and this is ultra fine stuff, and this should pull it right in, and I'm going to get a good visual on everything just to double check, make sure everything's right where it's supposed to be. I'm all set with lapping the valves. Know I got a nice tight cylinder head here, and that's my biggest concern. One thing I'll point out: if you do lap these valves, they should go back. They have to go back into the same hole. That's the only way to do it. So if you lap this valve to this seat, keep them married, put it back together the same way. Next thing I'm going to do is I'm going to get the cylinder head all cleaned up, and then I'm going to dry fit my cams and make sure everything in there turns over fine. In other words, I'm going to put those cams in without any of the valve train. I'm just going to make sure that everything in there is rolling over nice. Alright, I got my cam cover on, and all the bolts on top all torqued down. And what I'm checking for, again, there's no valves in this head. All I'm checking for is to make sure that I've got free movement, no binding on these cams. Same thing over here. Everything here is turning over nice. A lot of times when these jobs come in the shop, these things, I mean, you can't even turn them over without putting a wrench on them. That's caused from over torque on these bolts here. There's not a lot of torque on them, and a lot of people, they don't believe in torque wrenches. I guess they just throw a socket and a ratchet on this thing and just tighten it up and think that that's better. It's not. What it does is it distorts this cover or your caps, whatever you have. So absolutely crucial you get the right torque on this. So this is in fine shape. If these were bound up, we can fix them. There's ways we can lap these cams in and deburr things on the inside, and we've never had a problem doing that. But just be careful when you put these on. I'm going to pull these cams back out. I'm going to clean everything again, and then assemble a valve train. At this point, I have everything as clean as it's possibly going to get. I'm going to use a couple of different lubes here. What I have in the back, this is just Moly lube, 50-50 mix with 30-weight engine oil, and I'm going to use both of those to put this together. Basically, I just lube the face of the valve with the 30-weight, and I use a half and half mix to lube the stem. So I'm going to go ahead and do that and just get the valves in their prospective holes. And again, don't mix the valves up. Keep them with the ones you lapped, the seats that you lapped. Next step is simply just roll the head around and put the retainers for the springs in next. The next step is going to be to put the valve seals on. Here's our valve seals, and just like any other seal, I'm not going to put this on dry. I'm going to put a little bit of lube just on that lip. I'm going to try not to get it inside of here. This is going to be around the valve guide, but I'm just going to drop it in this way, just a little drop. I'm going to do it with a brush. Right, I went ahead and I pushed my seals on. Just keep in mind when you're doing something like this, you can use a socket. I have a little Delrin. It's specially made just for putting valve seals in. It's got all different interchangeable tips, but you can use a socket, but just don't push on the center of the seal. Push on the outside, on the outer rim, on the steel part of it, and don't hammer them on. Just push them on. You'll feel them when they stop, and be very careful. Just drop those in. They're very delicate, but they do a good job. So valve seals are in. Next thing we're going to do is we're going to talk about the springs. Here's our valve springs. Whenever you're doing something like this, you can't assume anything. Sometimes they're all the same. In this case, on this particular model, all of the valve springs are the same. Check, make sure you're putting the right springs in. And the other thing is, mostly all of the motorcycles that I see in here, and to be honest with you, I haven't seen an exception, the paint on the top of these springs is going to be an indication of up. And there's another thing you can notice. See how the coil is tighter here than it is up here? That's the coil wind. I've never seen an exception to this in my life. Whenever the coil wind is tighter on one side, that always indicates bottom. And this would be where the keepers go in. This is the tool I use to assemble the springs. Basically, you just put this on the valve on one end. I like to take this and put this in a vise, actually. It's really easy. You have different adapters. This is going to go over over this part of it, which is going to go over the spring. You just turn that handle in. It compresses the spring, and then you can drop your keepers in. Well, basically it's this simple. You just compress the spring enough so you can get the keepers on your grooves. Sometimes that can be a problem. We got a few tricks for that. If you're running into a problem, you can't get everything locked in the groove, try some Vaseline. Put it on the end of the valve and then go in there with a pick, but get your keepers in there together at the same time. And then once you get to that point, just back this compressor right off. Make sure everything's going in the slot, and that's it. You're done. I'll continue and do all four valves the same way. These are the shims and buckets. These being shims, these being buckets. What this does is this slides into the head, it's a little bored part of the head. This slides right in, sits on top of the valve, and you put these shims in, and that's how you're going to adjust your valve lash. I know this isn't going to be right. I'm going to measure these, and I'm probably going to take 2/1000 off of each one. We have a kit that's all different sizes, so I'll use that as a starting point, and I'm going to put this together dry. I don't want any oil in here. That's just going to make for problems trying to take things apart later. The oil acts almost like an adhesive. So I'm going to drop it down to where I know it's going to be too much lash. Then I can get my feeler gauges in between the cam and the shim, get an accurate dimension, and then make changes from there. Got my cams in. The bad news about this, these shims, unlike a lot of the shims that you can get right from Weisco or you just buy the hot cam setups, these are kind of unique. My Kawasaki dealer, my local guy, didn't have them. I had to order them, so this put me back about a week. But the important thing to remember is I just went in, I took my dimensions with a feeler gauge off my old shims, and that gave me a baseline to start, and then I went ahead and ordered the other ones. These are kind of expensive too. These things are $13 a piece per shim, so it's nothing we have a big box of laying around. So we put that together. Next thing I'm going to do is take it apart again and then oil all of the buckets. I'll show you how we do that. Got my cams back out, buckets are out, and one thing I want to point out, when you take the buckets out, make sure you put them back in where you took your measurements from. They have to go back in the same spot. We've been conscientious of this the whole job anyway. And the shims, make sure when you put the shim in, that number, put the number down. If you put it up, the cam will wipe the number off, and it's just a lot easier because, I mean, you're going to be adjusting valves forever anyways. So if you have that number available to you, it's a lot easier when you have to do a valve adjustment. I'm going to lube the buckets with a half and half mix of Moly lube and just regular 1040 engine oil, and then get those back into the bores. I put the buckets in. One thing I didn't say in the last shot, between the shim and the bucket, I just use engine oil in there straight, one drop 1040, and swish it around a little bit. Then I use the half and half Moly, get the buckets in, and same thing on top of the shims. At this point, because it's making contact with the cam and it's a high impact lube, I use that half and half. If these were new cams, and there's nothing wrong with these, but if these were new cams, they'd need a break-in, and I would just use that Moly lube straight on it. As far as the journals for the camshafts, straight engine oil there. I'll do the same thing on the cover, and next thing I'm going to do is put the cams in and get that cover put on. Well, that's the end result. Got the cams in, cover back on, everything lubed up. And again, the customer's going to have to take the cover off and the cams out to torque the head onto the back onto the top of the engine. So these are just, you know, these aren't torqued, they're just loose. But I'm going to bag this, tag it, and get the cylinder cleaned up next. Well, here's a shot of the cylinder. This was, again, we bored this thing out, and just going to do the final cleaning on it. And again, anything we ship to you like this, you should be cleaning it when you get it there anyway. We're going to assume that you don't. Well, we do the best we can, but all I'm using is some WD-40 in here. I just shoot the cylinder down, and that'll lift most of the crap out of it. You just want to wipe it in this direction, not up and down, and just, you know, take most of it off. You want to come out with a clean rag, and we're getting there. Last thing I'm going to do is just oil this thing up, pack it up, and ship it to the customer. CamelConnerRacing.com. Thanks for watching.